My screen is visible, right, students? Yes, thank you, Pa. In last class, what we have discussed? Today, I'm going to discuss about last topic. Okay. Then we will complete our first unit. Okay, fine. Hey, students, tell me in last class what we have discussed about proof and methods used to prove the particular theorem, like that, right? And seen some of the theorems. Is anyone please what is meant by contrapositive and contradiction? 148 people's only in the meet. Is tell me what is meant by contrapositive and contradiction? Students are in the meet, respond me, Pa. What is meant by contrapositive? How we can prove the theorem with the help of contrapositive? Shall I point out anyone? Just try to recall, no issues. It is correct or wrong, no issues. Try to recall what is meant by contrapositive. How we can prove the theorem with the help of contrapositive. Is tell me. Is Leela, Nitya, are you there, ma? Can you help me? Pragnesya.
If the statement is like if A then B, then in contrapositive it will be like if not B then not A.
Okay, very good. Thank you, Leela. And what about contradiction? How we can do the contradiction theorem?
If H then C, we have to prove that H and not C implies falsehood.
Okay, very good. Thank you so much, Leela and Nityasri. What about others? You are in the meet, but not focusing on concepts, right? Yes, Ritika, Gautam, Ramya. What about you guys? Sanjay, Saravanan, Santosh. Try to answer me. Okay. Okay. Today I'm going to so in that basis of contrapositive contradiction, we just prove the some of the theorems and started the inductive proof, right? In that, one of the important questions here, inductive proof is nothing but is a recursive kind of proof. Okay, we have to take each and every step, or we can say n equal to 0, n is 1, n equal to 2, like that we have to take and do the same problem. Okay, that's why it's called recursive one. Okay. It is a special form of proof called inductive, essential when dealing with recursively defined object. Okay, it is mainly talk about recursively defined object. We are going to do recursive process here. Okay, so many of the most familiar inductive proof deals with the integers, but in some cases we are doing with recursively defined concept like trees and expression of various sorts of such as regular expression. Okay, mainly we are dealing, I mean, we are using the inductive proof in the integer. Okay, integer means integer based problem, or like that. Okay, in some cases we are using the recursively defined concept. Okay, where we are using the recursively defined concept. For example, in the case of tree, we have recursively defined branches, right? Tree have many branches with recursively defined one. So so in that case we can use the inductive proof. Okay, inductive proof is nothing but it is a recursive kind of proof which consists of sequence of parameterized statement that use the statement that use the statement itself. Okay, with lower values of its parameter. Okay, this is the inductive proof. Here we have three types, but most of the things we are using only the integer. Okay, we have one important problem in induction on integer. We will see how we can. For that, we have some steps. That is nothing but we are the problem means just they given the statement. Okay, and involving with natural number. For that, we have to do what? We have to do the statement is true for n equal to 1. Okay, we have to substitute n equal to 1 in that particular given statement. Okay, given statement or given equation. Okay, if the statement is true, again, this is the initial. Okay, in inductive we have two steps. One is basis, another one is inductive. Okay, in the case of basis, we have we can apply n equal to 0 or n equal to 1. If particular equation is start with 0, then you have to apply with n equal to 0. Just we are going to what? We are going to assume different value for the variable n and substitute the particular n into the equation and try to find or try to prove both the left hand side and right hand side are equal. Okay, this is the process we are going to do. Okay, so the first step, initial basis step, we are going to do with n equal to 0 or n equal to 1. The second one, we are going to substitute k and k plus 1 for the value for the variable n. Okay, n equal to 1. This is the base. Next one is n equal to k, and next one n equal to k plus 1. We are going to substitute these value into the particular given statement and try to prove both the things are equal. Okay, both the things means particular equation is proved. Okay, okay, these are the steps for doing problem. This is the first induction. We have three types: induction on integer. Next one is the structural induction, is nothing but recursively defined structure. For example, tree. Once we are going to define a tree, we have recursively defined structure, right? Tree is like this, and each and every branch is having some same property like that. So we can say tree is one of the example for structural induction. Okay, no need to go inside into the structural induction. You have to know what is in the structural induction and example for that. Okay, in the basic step here, in the case of structural, this is for integer. This is an important one. And in the case of structural, we have to do with show that the result holds for all elements which were in the basic step of the recursive defined to be in the set. Okay, just we are going to do what? Recursive definition. Okay, we know already manual. For example, if you are taking the tree, we know this is the recursive definition. Like that we are going to prove. Okay, once both the structural and mutual not using in practically it is not used. Induction on integer only used, but you have to know what is meant by that. Okay, the recursive step here is, this is nothing but we have to show the particular statement is true for each and every iteration, each and every branches or each and every elements. Okay, for each of the element is to be construct new element based on the previous one, based on the initial condition or based on the basic step. Okay, this is the recursive step here. All are nothing but the same thing. In the case of basics means we have to do with the initial one. Okay, elementary structure we have to go with the, in this case we are taking the initial value n equal to 0 or n equal to 1. Here we are this is the structural induction, right? So we have to go with the elementary structure. We have to take a simple structure, I mean single node. Okay, if you are taking the tree means you have to take single node in that, based on that we are deriving the problem. Okay, and inductive step is nothing but next one, we are just incrementing the values. Now for example, elementary structure in the case of structural induction means if we are taking the tree, then you can say one node is the elementary structure. Okay, without the particular tree is non-empty, having some elements, but that is minimum one. We have to check, or we have to go through, or we have to prove with all the ways, all the condition of the particular problem. I mean, start with the initial and up to the maximum one. Okay, n equal to 0 is the minimum level, n equal to k or n equal to n is the maximum level. So we have to, that is why it's called recursive process. Okay, you start for each and every element in the n, we are going to substitute. We are not possible to show all the elements, right? N equal to 0, and what is the value of n equal to 1, n equal to 2, n equal to 3? We can't able to do. That's why we are doing what? Start with the initial value and take the middle value and go with the highest value also. So we can, if the both the things, both the three elements are true, means I can say yes, the particular theorem is proved. Okay. This is the example for structural induction. We have one tree with the number of nodes. Okay. Again, this is one subtree, tree 1, tree 2, tree k, like that. We can have, all are recursively defined, right? It may have a node n1, here n2, here nk, like that. So all are defined in the same manner only. So we can say this is the recursively defined problem. Okay. Okay. Recursive definition of a non-empty tree. If it is, if you are taking the particular tree as a non-empty, that means it meaning that having some elements. Okay. So I can say the single node or particular tree is a non-empty means having some elements. Okay. I'm connected, right? Can you able to hear me, students?
Yes, ma'am.
Okay, thank you. So particular trees, we can say if it is a non-empty tree, so it means that having some elements or having some nodes. For example, minimum we have single node. It means that if a particular tree is having single node, then the particular node may be the root of the tree. Okay, this is the recursive definition. We have more trees means with the non-empty means we have more nodes, n1, n2, n3, like that. How we can create a new tree? With the help of new node and edges. Okay, with the new node and new edges, I can create a new tree. Okay, and we can say this is the number of node v, vertex. Okay, we can say this is the number of nodes in the tree denoted by this one, and number of edges of a non-empty tree. Okay, this is the recursive definition of tree. Why we are saying tree is the example for structural induction, means this is the one. Okay, from this only we can say the tree is the example for structural induction. Structural induction is nothing but, induction means repeated process, recursive process, or likewise we can say structural induction means recursive defined object based on the structure. Okay, so this is the structural induction. There is no problem under this topic. Induction on integer is very, very important. In that only we have problems. We will see after this mutual. Mutual induction is nothing but, induction means what? A repeated process or recursive process. Mutual means you can say switch like on or off. Okay. We can say the mutual induction in the form of this one. Okay. First you can trigger, like trigger. If you press the switch, then it the fan or the light will be on, right? Next you press the same switch again, means it will be off, like that. So you can say this is the mutual. Okay. If it is on and if you pressed, it will be on. Next you do the same process, it will be off. Okay, this is the mutual induction. This is the example for mutual induction with the help of automation diagram. Okay, we can say the both the operation can explain the operation of switch. Okay, so this is the mutual induction. You have to know what are the types: induction on integer. Okay, the second one structural induction and mutual induction. In the case of structural, we have the example of tree, and mutual I can have one automation with the process of switch. Okay, this is the problem in induction on integer. Okay, likewise they give proved by mathematical induction. Okay, have you studied this topic in discrete mathematics, ma?
Yes, ma'am.
Oh, then good. How we can do? We have to take with a basis step. Basis is nothing but we can take the minimum value for the particular equation or statement. Okay, here the minimum value is nothing but what? 1. So I can take with the n equal to 1. If it is starts from 0 means, then I have to do with n equal to 0. Okay, otherwise you can go with n equal to 0, n equal to 1. This is the base case. Okay, and we have to apply the value 1 to the 1 to this statement, because we just assume that n equal to 1 here. In this case, if for example 1 means, what is the left hand side here? I'm going to apply n equal to 1 in the left hand side. What is the value? This is how we can see, all of you, this is an important question. How we can do this prove by mathematical induction. Okay, they may give any statement or any equation or expression to solve like this. So first step is nothing but we have to go with the basis. Okay, basis is meaning that we are going to take the initial value and apply that initial value to the equation. Okay, this is the first step. So we can go with 0 or 1. If it is mentioned with 0, for example, I can rephrase this statement in the form of like this, right? I equal to here 1. Sometimes it may be start with 0. Then you have to go with the n equal to 0. Okay, now here I equal to 1 to n. Okay, this is the way I can represent, right? So this is the meaning that it is equal to the this statement. So I can say the particular n starts from 1 to n. So I have to assign the value 1 to the variable n. So I have going to apply the this n value to this statement. Then tell me what is the answer of left hand side. Can you able to follow? Guys, just I'm taking this statement, and for this statement I'm doing what? I just assuming the some values to these statements. Okay, for that I'm taking the variable n. Okay, in that variable I'm assuming some values for each and every step with the different value, and substitute the particular value to the statement, and going to prove both the left hand side and right hand side are equal. Already this theorem is proved. We know in max 1 plus 2 plus 3 plus etc plus n equal to it, meaning that n equal to n plus 1 divided by 2. We know already. Just we are going to prove this with the help of mathematical induction. Induction is nothing but recursive process. So I start with n equal to 1. Now I'm going to n equal to 1 means I'm going to put the value 1 in the case of n. Okay, wherever I find the variable n, I just replace with the value 1. Now please apply this 1 to the left hand side. This is the left hand side, right? To this n, this is the left hand side, and here this is the right hand side. So apply the value 1 to the left hand side and tell me the answer.
1, ma'am.
1. Okay. So the left hand side is 1. Okay. And apply this 1 to the right hand side. What is the answer?
1, ma'am.
1 into 1 plus 1 divided by 2. 1 plus 1 is 2. 1 into 2 again 2. 2 divided by 2. Okay. So the answer is 1. So I can say left hand side and right hand side both are equal. Okay. Is it clear? So I'm going to do next step. The second step is nothing but I can say this is the induction hypothesis. Okay. So here I'm going to substitute the value n equal to k. Before that I substituted what? N equal to 1. Now I'm going to substitute the value n equal to k. So how can I do? 1 plus 2 plus 3 plus etc plus k. Is it so? This is the left hand side. I'm just substituting the k value into the n. Okay. And here, what about the right hand side? What about the right hand side?
K into k plus 1 by 2.
Yes. K into k plus 1 by 2. Here I'm having in the case of left hand side, I'm having, what is that? 1 plus 2 plus 3 plus etc plus k, that is equal to 1 plus 2 plus 3 plus in the case of n, I just replace with the k into k plus 1 divided by 2. Okay. This is the right answer, and just substituting the n value to this equation. Okay. K into k plus 1 divided by 2. Okay. This is my value. From n equal to k, I'm getting this value. I can make this, this is the equation number 1. Okay. I just make this as a equation number 1. Okay, fine. Now, already we know, right? First of all, we are going to do n equal to 0 or n equal to 1. Next, n equal to k. The third one is the n equal to k plus 1. I'm going to substitute the k plus 1 to the variable n. Okay, we'll see. Here going to substitute n equal to k plus 1. Okay, k plus 1 means here I'm going to substitute the value k plus 1. So first of all, I'm taking the left hand side. What is the values in left hand side? 1 plus 2 plus 3 plus etc plus k plus 1. Okay. Okay. Just I'm taking the left hand side, ma. This is the left hand side. In this, I'm substituted the value k plus 1 instead of n. Okay. Just I'm taking the 1, 2 plus 3 plus k plus 1. Why? How this k will come means I'm going to substitute what? N equal to k plus 1. So 1 plus 2 plus 3 plus etc plus k plus 1. So this is the k plus 1th term means which one is the previous one? Exactly the kth term. Okay. So just mark like this. This is the meaning 1 plus 2 plus 3 plus etc. plus k plus 1. This is the meaning that the k plus 1th step is the last step, means the previous step should be k. So I just mentioned here, and I just replacing this value 1 equals 1 plus 2 plus 3 plus etc. plus k. Up to this I can replace k into k plus 1 divided by 2. Is it so? From the statement, from the given statement, I can say 1 into 1 plus 2 plus 3 plus etc. n equal to, meaning that n equal to n plus 1 divided by 2. So here it is in the meaning of k. So I can say k into k plus 1 divided by 2. Again, another one term is that is k plus 1. Okay. So in that, we have two terms. In that I can take the common term out, right? So k plus 1, I take the common term out. Then remaining, what is that? Here k by 2. Here no value. So I can say this is the 1. Just take the k plus 1. In both the terms, k plus 1 is the common value, common term. So I can take the particular k plus 1 in from both the things and write in the outside. Okay, k plus 1. I have to write the remainder. You know this concept already, you may studied in maths. Okay, just utilize the max here. So k plus 1 is outside, k by 2 plus 1. Again, I'm going to do what? For example, you know, right, how to solve the equation, how to optimize this equation. K by 2 plus 1. How we can optimize this? We have to take LCM for this and to make, right? So what is the answer? I can take this is 2 and here k and k plus 1. Okay, take the LCM as 2 like this. K by 2 plus 1, then k plus 2 divided by 2. How? LCM is 2 only, no? K, yes, k plus 2. Here we need to multiply, right? So the answer is k plus 2 divided by 2. Can you able to follow, all of you? Can you able to follow? Okay, ma'am. Thank you. So k plus 2 divided by 2. Okay. I just take the LCM for this. I just want to optimize this. Take the LCM. Here the 2 and k. Here no. Here the value is 1. So I just want to multiply with 2. So here 2 and below. So k plus 2 by 2. Then I'm going to do what? I can do this again. I can do this by k plus 1 k. I just this 2 is divided into plus 1 plus 1. Okay, just I just replace this 2 by plus 1 plus 1. Okay, for substituting some values. Okay, k plus 1, here k plus 1 plus 1, the same thing, k plus 1. Yes, okay, we got. It means I'm just doing what? Just replace this 2 by plus 1 plus 1. Okay. After that, I got k plus 1, k plus 2 divided by 2. It is meaning that if you are substituting n equal to k plus 1 in the right side, what is the value? If you are substituting n equal to k plus 1 in the right side, what is the value? K plus 1 into k plus 1 plus 1 divided by 2. So we got the right hand side. Okay. I'm just taking, I'm just substituting n equal to k plus 1 in the left hand side and do this process. Finally, I got the output in the right hand side. Okay. Is it clear, everyone? Any doubt, ma? No need to worry about here. Just we are going to do what?
Yes, ma'am, it's clear.
This, okay, ma. Just substituting the base case, that is n equal to 0 or n equal to 1. Then induction. In this induction, we are going to substitute n equal to k and k plus 1. Okay. Just substituting these values in the equation and want to prove that both the left hand side and right hand side are equal. Okay. I have another one example. Please try and tell me. All of you, I want answer from all those things. I will expect more than 20 people want to interact with me. Try this, ma. Try this and update me the same procedure. First of all, you are going with a base case. Just substituting the n equal to 1. This is the initial one. So you can substitute n equal to 1. Okay. And next one is the induction, n equal to k and n equal to k plus 1. Substitute and try to get the answer left hand side equal to. Another one thing you have to note this, here the problem is given that prove already. So they informed that is prove. So we have to do what? We have to prove that both the things are equal. Okay, already in problem statement, from the problem statement, we have to know both the things are equal. Just want to do what? Trying to prove that. Okay. So do and update me, all of you. Have you noted this problem? The given statement itself, they informed us both the left hand side and right hand side equal only. Okay. So keep in that mind and trying to prove. Have you noted this problem? Are you doing? Anyone give me a reply?
Yes, ma'am, trying to solve.
Okay. This is n squared, ma.
Yes, ma'am, solved. Completed.
Okay, ma. Who completed? Who completed?
4076.
Reshma. Okay,
Yes.
okay. Any others completed? All of you completed? Students, respond me. All of
Yes,
you
ma'am.
is
Yes,
Nitya
ma'am.
completed, Jacob completed, Reshma completed. What about others?
Yes, ma'am.
Yes, Leela also completed. What about others?
Yes, ma'am.
Yes. Ikshita. Abita, number 4. Are you in the meet, ma? Just number 4. Abita, are you in the meet? Unmute and speak. If I call you, how to respond? Otherwise, you are not in the meet. I have to put absent for you, right? Abita, are you in the meet? Unmute and speak, ma. Have you completed this problem? Is Anusha or number 11? Are you in the meet? Anusha? Are you in the meet, ma? No. Bharat? Number 22? Are you in the meet? Tilagvadi ma'am?
Yes, ma'am.
Ma'am, no one
Yes, ma'am.
responding, ma'am. They are in the meet or not, I don't know.
See, what is
Nitish?
the students? They are doing like this only, ma'am. See, what's the difficulty, students? You just tell now you're there or not. Huh? See, then we'll be giving you absent. That's all. We can't do anything.
Yes, ma'am, I will.
So next class we won't allow you. That's the only thing. If you're not, you must at least see 10 students call names of card. At least 8 of you should answer, no? Okay, at least 50% should answer. Unmute and talk. No, what's the difficulty? How do we know you're in the class or not? Tell me. You're calling out your name. This is a basic discipline, right? If you're okay, in 10 members' names are called, at least 5 can answer, right? Abita, you're there or not, Abita? Unmute and talk, Abita. It's a problematic paper. It's not theory where you can learn on your own. Huh? You're keeping on calling out your names. You're not there. We'll put mark absent, and tomorrow if they come, no need to allow them. We'll do like that, ma'am.
Okay, ma'am.
Yes, we have the option to remove them.
Okay, ma'am.
Sabita also could be removed. What's the use of simply calling out their names? Huh? Or we'll ask them to come in video next time, sitting with a paper. Then we'll know they are listening or not. I'll talk with HOD, ma'am. All the students from tomorrow will be joining in video with formal dress, with your ID card, with a notebook in front of you. Okay? So I'll talk with HOD, ma'am. From tomorrow we can do this. Then what you will do? Then we'll know where you're seeing, you're answering or not, whether you're sitting in the place or not, you can find out. That's the only option for this class. They'll switch on and they will go somewhere, do their own work and come, I believe. Very bad. So one time it's happening now, no problem. In my class, I'm calling out your names, no response. In all the teachers calling out, only the regular people are responding. I know the regular students who are responding in all the class. Very bad. Ma'am, we'll mark them absent, ma'am. Why to waste time on them?
Okay, ma'am. Okay.
We'll concentrate only on the students who are listening.
Okay, ma'am. Okay, fine. Check with your answers, ma. Here. Have you got like this?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
Okay, ma'am. I will give another one problem. That is, you have to prove 1 cube plus 2 cube plus 3 cube. Please note it. 1 cube plus 2 cube plus 3 cube plus etc. plus n cube is equal to n square into n plus 1 the whole square divided by 4 by mathematical induction. Okay. Shall I repeat?
Ma'am, yes, ma'am. Yes, ma'am. Can you repeat?
Yes, ma'am.
Okay.
Can you repeat?
1 cube plus 2 cube plus 3 cube plus etc. plus n cube is equal to n square into n plus 1 the whole square divided by 4. Prove this statement. Okay. Prove this statement by mathematical induction. Do an update, Mima. Up to this, our first unit is completed. Okay. The conversion problem and the mathematical induction problem is very, very important. In theorem, ceiling of x equal to floor of x. That theorem is very, very important. Anyone completed? Can you able to solve?
Yes, ma'am. Solving.
Solved, ma'am. Yes, ma'am.
Okay, good. Okay. Our first unit is over. Just I want to recall first unit. Okay, with the help of digital content. See here. What are the topics in first unit? All the things we have covered. Introduction to formal proof, additional forms of proof and inductive proof. Okay. And finite automata, DFA, NFA, and NFA with epsilon. Okay. Here we have some definition about computation. Just introduction. And now only enter into the automata. What is mean by automata? For that we have some definition and application of automata. We have application of automata theory is very, very important. Okay, please note this. Application of automata theory, it is mainly play vital role in compiler design. Okay, to prove the correctness of the program, automata theory is used. Switching theory and design analysis of digital circuits, automata theory is applied. Okay.
Ma'am, did you change the slide, ma'am?
Yes, Pa.
It is still an example to prove by mathematical induction, ma'am.
Okay, ma. Okay. Thank you, ma. I will update. Now able to see?
Yes, ma'am.
Okay. So automata and automata theory and what is the application? Okay. Here language and automata is mentioned in diagram, and the language we will learn in the next unit, second unit. Next one is the introduction to formal proof. Okay, we have two statements. If H, then C. Then next one is the if H, if and only if C. Okay, two statements for that explanation. And what are the various forms of proof? Deductive, contrapositive, contradiction, induction. In that induction, again we have three types. Mathematical induction, otherwise we can say induction on integers. Okay, both are same. Then structural and mutual. Okay, these are the basic proofs we may use in the TOC concept. And what is deductive? Deductive proof is nothing but it is which one is the example for deductive proof? If H, then C. Okay, based on this condition, based on the initial statement, we can conclude. Okay. But in the case of inductive, how we did? We have the initial condition and we taken the middle element and take the maximum element. Okay. Compare the three things and substitute these three values into the statement and try to conclude. Okay. So inductive is the recursive process, but deductive, based on the initial condition, just we try to give the conclusion. Okay. Theorem. Example for if H, then C, and if H, if and only if C. And proving equivalence. What are the techniques we have to prove? Proving about sets, and what are the things, ma? Proving by contradiction, that is the contrapositive and contradiction. The third one is the proving by counter example. Okay, these are the techniques we have to prove the particular theorem or concept. You have seen this. Then mathematical induction. Then now enter in the concept of automata theory. In the first class we have seen, right, what are the things in basic terminologies or basic elements in the automata. Alphabet, we know what is the alphabet, right? Alphabet. How we can represent this is the input symbol. Okay, an alphabet of two symbols A and B. Next one is the string. What is the string? With the help of the input, what are the strings we can develop? Okay, we have to know. Based on this only we are constructing the DFA and NFA. So here see, the input is nothing but A, B, With the help of this input, we can develop this much string. Okay, if they mentioned any condition, for example, we have to start with A, or we have to end with A, or we need to have even number of A, even number of B. If they mention, we have to do with that. Otherwise, we can go any possible number of inputs. Okay, any possible way we can give A, B, and but we are going to do use what, just A and B only. Okay, so A B B A B A B A B, like that. Anything it may be, based on input we can derive some strings. Okay, and some operation, operation on strings, length of the string. Okay, how we can calculate the length, we know, right? A B C D. So particular length of the W, the word W is 4. And empty means we know how we can represent the empty, the epsilon. Okay, we can say that is the null string. We can denote by pi also. And concatenation, how we can concat, as usual, how we can here also we can do like that. X equal to 0 1 0, y equal to 1, and then we can concatenate like 0 1 0. Okay, and reverse of, these are the basic operations in the automata. Reverse of a string, power of an alphabet, this concept only I have missed, that is clean closure. I have forgot that one. Clean closure, this is one of the concept or one of the operation in automata. Okay, see here, clean closure is nothing but we are going to derive the strings. Okay, we can mention in another name, I can say this is the star closure. Okay, clean closure or star closure. This is nothing but denotes the set of all strings over the input summation. Okay, over the alphabet, over the input. Okay, we can say clean closure is nothing but it denotes the set of all strings over the alphabet. Okay, so here the epsilon is with the input symbol A. Epsilon star is nothing but we can clean closure is nothing but it is a possible set of all string that include the empty also. Okay, first you have to start with the epsilon, then A, and triple A, and 4A, 5, like that. Okay, this is the clean closure concept. Okay, this is an important 2 more question I just missed in the slide. So here, for example, in the next example, they given as the input simple, they mentioned the alphabet as 0 and 1. Clean closure is nothing but denotes the set of all strings over the input with the inclusion of empty string also. Okay, empty string denoted by epsilon, comma. We can say no condition is mentioned here. Clean closure is nothing but it's a possible set of strings over the alphabet. So I can say 0 1 0 0 1 1 0 0, etc. Okay, it's going. So this is the clean closure concept. This is the important one. Please, all of you, make a note. What is in by clean closure? Clean closure is nothing but it denotes the set of all strings over the alphabet. Okay. And substring, we know what is in by substring, right? And palindrome. Operation, properties of string operation, and languages. What is my language? A set of strings from an alphabet is called a language. Okay. Here with example, you please note, binary string is nothing, it is one of the language with the alphabet 0 and 1. You can say English is the language over the letters A to Z. Okay, this is the meaning of language in the automata. And some of the notations, empty string or null string denoted by this one. and finite automata. This is the definition for finite automata. We have two types, DFA and NFA. Example for that, if they are asking 2 marks, define finite automata, means you have to give the definition, and so with example is very, very important. If you go with a definition example, definitely you will get full marks. Okay. And DFA, you have to mention all those things. Okay. DFA is what, and it is consists of 5 tuples, like that you have to mention. Then what's the transition diagram? We know transition table, right? In transition table, in the row wise, we have to mention the states, and the column wise we have to mention the input symbol. And we know how we can find the transition function, right? Transition function. Please go through. I will today I will upload all those things in the Google Classroom. Please refer all those things. If you have any doubt, ask me. And so today I plan to upload the assignment 1. Okay, try to complete within the time. NFA. Here the difference is mentioned. And construction of NFA, we know, right? Accepting all things that end with 0, 1. Here they given 0, 1. So the minimum length is 2. So we have to go with the 3 states. 2 plus 1, 3 states. So Q0, Q1, Q2. The what condition they mentioned directly, we can give the transition. Q0 to Q1 0 and Q1 to Q2 1. In NFA, no need to go with all the states with all the input symbol. If 0, 1 is we have to do what? All things end with 0, 1. So before that, no need to go further, no need to go with the end, because already defined, that is end with the 0, 1. So in the start case, you can give 0 or 1. You know, right? What is my DFA and what is my NFA? So in the NFA, I can with a single state, from the current state, I can read more than one input symbol, and I can go with more than one state. Okay, this is the NFA. Like that, we have some problems and with the epsilon transition. Here also we have one definition, NFA with epsilon. And we know epsilon closure, right? What is in the epsilon closure? Epsilon closure of 1 means we have to include the particular star state, and from that state, with reading the input symbol epsilon, we just move further states. Okay, this is the epsilon closure. And equivalence problem. Equivalence, where we have 3 types: NFA to DFA, NFA with epsilon to NFA without epsilon, and NFA with epsilon to DFA directly. Okay, go through all those things. If you have any doubt, please contact me. I will update you. I will help you to okay, all the conversion problems, then assignment 2 marks, part B question. Please refer all those things, ma. Then only some doubts may arise. Okay, and some online courses, certification courses also given. Please try to refer. And real-time application, content beyond syllabus, and what is that? Textbooks. Here I have mentioned the textbook also. I will share that link of textbook. Okay, please refer that also. Okay, the time is over, I think so. From Monday onwards, we'll see the second unit. Okay, thank you, students.
Thank you, ma'am.
Thank you, ma'am.
Yes, thank you, Pa. You can leave.